Hi, my name is William. I'm the math instructor. So this semester I teach Precalculus. Today, as usual, we cover the next section. So we are still in chapter 1, functions and their graphs. As you see in your syllabus, every class or every day we start and finish one section. So today we are going to start and also finish this section 1.9, inverse function. 1. Inverse operation. In our daily life, for example, original operation is like open the car door, step 1. Then step 2, start the engine. That's happened in our everyday life. Then the inverse operation, we will inverse the second step first. Then we inverse the first step. So the order for the inverse operation here is we inverse step 2, that is turn off the engine. Then we inverse step 1, that is close the car door. So the order is step 1, step 2, that's the original. Then inverse step 2, inverse step 1. Next, we say one example in math. Original operation or function, that is y equals x over 2 plus 1. Now you have done the math operation, right? Since high school, you know that math operation will have addition, subtraction, multiplication, and division. Right? So, of course, we do multiplication and division first. Then we do addition and subtraction. Right? So here, in this math operation, the first step, of course, that is x divided by 2. We do that division first. That's our first step. Then our second step, we'll do the addition plus 1, right? So, you want to write down what step 1, step 2 here. Step 1, half of x, that's the division, right? Then step 2, plus 1, that's this. Then, by the above rule, the inverse operation or the inverse function should be we will inverse that step 2 first. So since step 2 is plus 1, inverse of that, of course, that will be minus 1. So step 2 inverse first is minus 1. Then we will inverse step 1. Let me make this brighter. So, inverse step 1, since step 1 in the original is half of the x, then as you can imagine, we inverse of that will be, we double it, right? Original, half of it, or divide by 2, right? Then we inverse that will be double it or multiply by 2, right? So here, in the inverse, the first step will be this one, inverse 2 will be x minus 1, right? Minus 1, right? Then step 2 of that inverse, double it, then 2 will multiply that parentheses. We use parentheses to show this -1 is our first step in the inverse operation, right? Any questions on that? Well, this is just my lecture, and we can only do video without students, so I just show how the procedure is. Today this classroom has no students. That's how I can make the video, right? In my regular teaching, there are about 30 students in this Precalculus classroom. Like any college, each class will have 50 minutes, 50 minutes, right? All right. Well, imagine my students do not ask any questions, or if they ask, I will answer them, okay? So, just imagine some silence, then in each of my class, I require my students to take notes on every word of this white screen or smartboard. Every typed word on smartboard, students are supposed to take notes. And usually, blue color, that means the solution. Then brown color, that means assignment or the student's time to work. So the following, you see this brown color, that means your turn to work. Original operation or function, go upstairs and enter the room. That is our problem number 1. Then problem number 2, y equals 3x minus 1. So there are 2 problems here with original. Find their respective inverse operation or function. Everyone do this, volunteer come to the board. All right, here I walk around the classroom. If I find some students are able to do the problem, then I will call those students to the board. All right. Just imagine, Jason, can you write yours to the whiteboard? Okay, now I pretend to be my student Jason. Okay, I come to the whiteboard, do the problem. All right, I pretend my student Jason finish the solution on the whiteboard. And I will say to the class, all right, now, first let's look at the work of your classmate. Thank you, Jason. The first one, go upstairs and then enter the room. So when we do inverse, we inverse the second part first. Enter the room will be leave the room. Then the first step, inverse go upstairs will be go downstairs. So this is correct. I mean, some people may wonder, how about we do it the other way? You cannot, okay? Just like I will show you the above example. For example, here, open the car door, then start the engine, right? You want to inverse it. You have to turn off the engine first, then close the car door, right? If you want to do it the other way, you want to close the car door first. I mean, after you close the car door, how can you turn off the engine, right? So you have to inverse the second step first. Then you inverse the first step, right? The same as here, right? Again, some people may wonder, how about I inverse the first step first? You want to go downstairs, right? Then how can you leave that room, right? You already go downstairs, right? So that means the order, if you do not inverse the second step first, then it just will be absurd, right? And you cannot do it. So we must inverse the second step first. All right, the second problem. First, we identify here, Jason did very good. He identified the step 1 is 3x, then step 2 is minus 1, right? So to inverse that, we want to inverse the second step, minus 1 first, that means add 1, right? Of course, that means x add 1, right? So will be x add 1, then parentheses, divide by 3, right? Here, my solution is about the same with Jason's, okay? The first one, leave the room, then go downstairs. Then the second one, the original. First, identify the first step, multiply 3, then second step minus 1, which is this one, right? Then the inverse, we inverse the second step first. So, second step, original is minus 1, so we inverse that will be plus 1. Then the first step is multiply 3. We inverse will be divide by 3, right? So the inverse function will be first, of course, that's x plus 1, right? Will be x plus 1, then parentheses divide by 3. Any questions on this? Are we good at the notes for this page? Usually, at this moment, I give them the class 1 minute to write down all the notes of this page. Alright. Now we move to the next page. Two, only one-to-one function can have inverse function. One-to-one, that means different x will have different y. So to find whether a function is one-to-one function, we use the horizontal line test. The following is two examples. In the graph below, horizontal line can have only one intersection with the graph. And also vertical line can have only one intersection with the graph. You know, vertical line test, that is to find whether an equation is a function or not, right? So, for example, in the following two graphs, first, the left one. So this, imagine my marker is the horizontal line. So, my horizontal line moving from top to bottom, right? Is there any place the horizontal line has more than one intersection with this orange line? Yes or no? No, right? Again, the vertical line test. Again, imagine my marker is the vertical line. I'm moving my marker from left to right, right? Is there any place the vertical line has more than one intersection with this orange line? Yes or no? No, right? So every place the graph has only one intersection with this vertical line. So that means this orange line, a straight line, that is a one-to-one function, right? So this, of course, this is a linear function, right? A straight line. Here, I write down linear function, cubic function are one-to-one functions and has inverse function, right? So the cubic function, that's the one on the right, right? You see this cubic purple line, purple curve. Now again, you use horizontal line test. My marker moving from top to the bottom. Is there any place my marker or the horizontal line has more than one intersection with this purple curve? Yes or no? No, right? Only one intersection at any given place. Again, if we use a vertical line test, my marker moving from the left to the right, is there any place my marker or the vertical line has more than one intersection with this purple graph? Yes or no? No, right? So, only one intersection with the vertical line, that means this is a function. And then for the horizontal line, again, only one intersection with this graph. That means this cubic function, that is a one-to-one function, and therefore it has inverse. Any questions on this? If no questions, then the following brown color, that means your turn to work. determine whether the following graph is one-to-one function and whether it can have inverse function. Everyone do this. Volunteer come to the whiteboard. So a one-to-one function should pass both the horizontal line test and the vertical line test, right? There are three problems, right? I mean, this one is quite straightforward. You just need to write down yes or no, right? It is a one-to-one, then it should have inverse, right? If it is not one-to-one, then it cannot have inverse. At this moment, usually I walk around the classroom to say whether some students can get this problem done. Ashley, can you write yours to the board? Okay, just now myself just pretend to be my student Ashley, okay? I'm the volunteer come to the board to do this problem, okay? Ashley come back to her seat. Thank you, Ashley. Now, let us first look at the work of your classmate. The first one, actually write down no, right? Because the first one, it says the vertical, it can pass the vertical line test, right? But it cannot pass the horizontal line test. The horizontal line has more than one intersection, actually two intersections with this graph. So the first one is not one-to-one and cannot have inverse. Then the second one, right? Second one can pass the horizontal line test. Also, it can pass the vertical line test. That means it is a one-to-one function, and therefore it has inverse. So the second one, that's yes, good. Then the third one, well, it cannot even pass the vertical line test. That means the third one is not a function. So since it is not a function, it is not one-to-one, and it cannot have inverse, right? Very good, Ashley. Get all the three correct. So now, my solution is about the same as Ashley's. Difference is that I use more words, okay, instead of just yes or no. So the first one, it is not one-to-one function and does not have inverse function. That's this one, the left one, okay. The second one, a straight line, right? Linear. It is one-to-one function and has inverse function, right? The third one, that's the one on the right, right? It is not function and does not have inverse function, right? Any questions on this? No questions. Are we good at the notes here? All right, then we'll move to the next page. Some people, they may worry about, finding the inverse function or operation is quite confusing to them, right? They feel I have to first identify which one is the first step, which one is the second step in the original, then I inverse the second one first, then the first one. It's quite complex and have a good chance to make mistake. Well, now we get better options. So 3, solve for x to get the inverse function. That is usually what we do to get the inverse. Here is one example. Find the inverse of fx equals x cubed minus 1. So we have 2 steps here. So first step, we solve for x. After we get the value of x, we switch. That's second step. We switch x and y. Take above as example. So first that's as I said, fx is the same as y. So this is y equals x cubed minus 1. Now to get x value, of course, we want to put x term, only x term on the one side of equal sign. So here will be x cubed equal y plus 1, right? Now we take cubic root on both sides. So x equals cubic root of y plus 1. Now we got x value. Step 1 is done. We have solved for x. Then step 2 is simple. We just switch x and y to get the inverse. Therefore, the inverse function is now x changed to y, and y changed to x. So y equals x plus 1, then take cubic root, right? Or you use inverse rotation, will be f inverse x equals x plus 1, then cubic root. Any questions on this? I mean, in most times, my students, after I talk about how to solve the problem, in most cases, they do not have questions. Sometimes they have. All right, since you don't have questions, next, as brown color, your turn to work. We have 2 problems here, right? Problem 1, y equals 3x plus 2. Problem 2, y equals x cubic root. Find the inverse of the 2. Everyone do this. Volunteer, come to the whiteboard. Again, usually this time I walk around the classroom. Paula, can you write yours to the whiteboard? All right. Now I imagine myself to be my student Paula, and I come to the whiteboard and do the problem. Thank you, Paula. Now, first, let's look at the work of your classmate. First, she solved for x. Again, move that x10 to the one side of equal sign. So 3x equals y minus 2. Then divide both sides by 3. So x equals y minus 2 over 3. We get x value. Then just switch x and y. Finally, inverse. Y equals x minus 2 over 3. That's right. Second one, we cube on both sides to get x value. X equals y cube. Then inverse, just switch x and y, right? So y equals x cube. Very good, Paula. Here, I did about the same thing, okay? The first one, move that x10 to the left side of equal sign, right? Then divide both sides by 3. So x equals y minus 2 over 3. Then inverse, just switch x and y. So inverse is y equals x minus 2 divided by 3. Or you use that inverse notation will be f inverse x equals, as I said, that is just y equals x minus 2, then divide by 3. Problem 2. We cube on both sides. That becomes y cube equals x. Now we get x value, right? Then we just switch x and y. So x, by convention, we write x on the left side of equal sign. So x equals y cube. Then the inverse, switch x and y, will just be y equals x cube. You know, that's how you find the inverse function, in our regular practice. Right? This is, I want to say, this route is simpler than the first one we mentioned at the beginning, right? This one you just get x value and then switch x and y, right? Any questions on this? Are we good at the notes here? While you are taking the notes, I say something that in your next examination, also the final examination, everyone should carry your student ID, right? Because in the past, there is some student cheating, right? He do not come to the class usually, then in the final he asks somebody else to take that final for him or her. So in your next examination, also the final, everyone bring your student ID for the examination, all right? All right. Now I think we are good at the notes. Move to the next page. Four, the graph of original and inverse. So the graph of these two symmetric across y equals x. Y equals x, we know that's just a straight line, right? I mark it here with this purple line, right? 45-degree angle. So here is one example. Original is fx equals 2x plus 1. Then the inverse will be x minus 1 divided by 2. Right? We know there are 2 points decide a line. So the original fx equals 2x plus 2. We can find is two points. One point is 0, 1. Of course, I mean when you do the graph for a straight line, usually you want to choose simple value for x, like x equals 0 or x equals 1, right? Or negative 1. So when x is 0, what's y here? Will be 0 plus 1, so y will be 1, right? Then the next point, you want to choose, again, simple value for x. Imagine x is negative 1. So negative 1 times 2, that's negative 2. Negative 2 plus 1, that is negative 1. So the second point is negative 1, which is this point, right? First point is 0, 1, right? Now we got the 2 points for this original. 2 points is enough to determine a straight line, right? So here, we connect these 2 points and then get this blue line, right? That is the original. The original one, I use blue color, right? This blue line. Then equation is y equals 2x plus 1, also blue color. Then the inverse, y equals x minus 1 over 2. Again, you want to use simple value for x. When x is 1, what is y? When x is 1, 1 minus 1 is 0. 0 divided by 2 is still 0. So the first point is 1, 0. Then the second point, we try negative 1 for x. So when x is negative 1, negative 1 minus 1, that is negative 2. Negative 2 divided by 2, that is negative 1. So the second point is negative 1. For the inverse, well, negative 1 is this point, right? Then 1, 0, that is this point, right? Now we get 2 points for the inverse. We connect that 2 points. We get this orange line, right? Which is the inverse. I use orange color, right? Orange color is for the inverse. Also, the inverse function y equals x minus 1 over 2. Also orange color, right? Now you observe on this orange line and this blue line, they are symmetric to this purple line, dotted purple line, right? Because the original, the blue line, and then the inverse, the orange line, they are inverse to each other, right? As we put before, it's symmetric across y equal x, which is this dotted purple line, right? Any questions on this? We say in this graph, if the original has a point AB, then the inverse should have a point BA, and vice versa, right? So how can you tell? Well, we can tell from these 2 points, right? The original one has 0, 1, then the inverse has 1, 0, right? 0, 1 is this point, which is in this blue line, original, right? Then the inverse has 1, 0, which is on this orange line, right? So that means original has a point AB, then inverse will have a point BA. But notice the sign do not change. The sign stays the same, only the order change. Alright? And the questions on this. The flow question. The following wrong color again. Your turn to work. So it says the inverse has 3 points. -4, 3, first point. Second point, -3, 2. Third point, 1, -5. What point should the original have? Everyone do this, and the volunteer come to the board. June, can you write yours to the board? Okay, I imagine I'm my student June. Okay, I come to the board and do this problem. So the original should have 3 points. Thank you, June. Now first, let's look at the work of your classmate. She write down the original has 3 points. 3 -4. That's good. Then 2 -3. For the second point, then the third point, -5, 1. That is correct. Okay? Here I do the same thing. Okay? The original should have 3 -4. You just switch A and B, right? Then the second point will be 2 -3. Third point, -5, 1. Remember, those signs stay the same. Sign do not change, only the order of x, y change. Alright? And the questions on this. Are we good at the notes here? Alright. So usually the vocabulary and homework is my last page for each section. So vocabulary for this section: inverse operation, inverse function, one-to-one function, horizontal line text, solve for x, switch x and y, symmetric approach y equals x. For the vocabulary, you should be able to make a sentence with each word in this vocabulary list. Alright? You usually one example. For example, inverse function. You may just say, suppose original function is y equals 2x, then the inverse function of it will be, you solve for x first, right? Then you switch x and y. So the inverse will be y equals x divided by 2 for y equal 2x as original, right? That is one example. That's how you do the vocabulary. Make sure you can make a sentence with each word in the vocabulary list. Vocabulary is just like a vocabulary to any subject is like a brick to a building, right? All right, homework. 1, read the textbook and the notes for every sentence. At least that as number 1 because that's the most important. You know what is behind, then you know how to do the problem, right? Remember the blue color for solution or steps. If you know the blue color, which is on my smartboard, that means you should get an A in the examination, right? Because all my problems, you should be able to find solution with those blue color, right? On my smartboard, of course. 2, website homework, that is up. If no questions, you have taken the notes here, then have a nice day. This is the end of this class. Thank you.